Today, we're going to be talking about angles, and that's a lot of things. Let's start with complementary, and we'll say supplementary angles. What do they mean? Why do we care? All right, let's say for complementary angles, I have two lines that are perpendicular to each other. What I mean by perpendicular, if you guys don't know, this is perpendicular, right? Okay, they're perpendicular, which means they cross and there is a 90-degree angle formed between them. And if we know this is 90 degrees, this is 90 degrees, they're all 90 degrees. Let's say I have a line that comes out here, and I have the angle A and the angle B. All right, I know that angle A plus angle B equals 90 degrees. And the reason I know that is because I have told you they're perpendicular, so on every corner, if that's how you want to call it, every angle here is going to be 90 degrees. If I cut that in some portion, right, they're not necessarily half, you know that the whole angle here is still 90 degrees, so whatever A is and whatever B is, we know they have to be 90. Supplementary is similar. Let's say I have just a line. We're going to have another line cutting through it. Here I'll say X and Y. Now, a line is 180 degrees. If we know that on this line it's 180 degrees, we also know that X plus Y has to equal 180 degrees. How do I remember the difference between complementary and supplementary? They're very similar. You have supplementary being an S, right? And you have complementary being a C. If you want, you can think of this S as just being able to be drawn into a 180, and you can think of the C being able to be drawn into a 9 for 90. Another way is to just think C comes before S in the alphabet, so C is smaller. If you were to count up, I would begin at C before I would get to S. Now we're going to talk about the vertical angles theorem. Theorem, just THM. For vertical angles theorem, we just have two different lines, that cut into each other, right? I'm going to say this first one is 110 degrees, all right? I'm going to use this to find every other angle here. Let's ignore this right now, right? I just have this line here, and it looks a lot like supplementary angles, right? I know that these two are on a line, so they have to equal 180. If I have 110, this has to be 70. Great. Well, let's ignore this and look at it the other way. If I'm looking at it this way, this also has to be 70. It's the same rule, same reason. And then I can look at it this way or this way to get this angle, and it is 110. And you might have seen a pattern here, and that's good. If they are opposite angles here, they are always going to be the same. That is the vertical angles theorem. Same side, interior angles. Let me draw two parallel lines, and let's say we just have a line cutting through them. Let's say this is A, B, and CD. Line AB is parallel to line CD. That's what those two lines next to each other means. It means they're parallel. We'll say this is 100 degrees. Because of supplementary angles, we know that this is going to be 80. But can I use this to figure out what these angles are? And the answer is yes. Because of the definition of parallel lines, they will never intersect, which means they are actually cutting through this horizontal line at the exact same angle, right? We know that they're going to just be the same because they are the same angles, right? They are parallel. Whichever way you shift them, they'll both shift the same. If I cut through there anywhere, they're going to be the same. Alternate interior angles. And over here, we will have alternate exterior angles. All right, I have two parallel lines. I have a line here. Let's make that a little bit more bold. Now, I can prove two different things here. And I'm going to show you how and why. When I say the alternate exterior angles, I'm referring to here and here, and here and here. Alternate interior, I'm talking about these four angles, right? The interior angles, the exterior angles. Let's start and say that I know that this is 70 degrees, right? Now, because of that, I know that this is going to be 110, right, because of the supplementary angles. I know that this is also going to be 70. This is also going to be 110, right, because of the vertical angles theorem. All right. From here, I can prove, because of the same side interior angles, that this is going to be 110. This is going to be 70, right? Again, that means this is 70 and this is 110. Now, color-coded this on purpose. We have this 70 and this 70 are the same. This 110, 110, 110, 110, 70, 70. The reason we can do this, I've walked through, but let's say you only knew one angle and you didn't want to go through all this. They were just asking the other. So for alternate interior, here you are. They say that this angle is 70 and this is x. Find x. The way this was taught to me, the thing that has stuck with me, usually when teachers try to get something to stick with a student, they will use something that is a little abnormal, a little unusual. My teacher, shout out to Mr. Livengood if he ever sees this video, he taught me that the easiest way to think about this is to think about it as a z. There's a z that crosses here, right? Z. We have a 70 here, the x here, right? And we're just going to elongate these on both sides, and that is what we have here, right? Elongate that, elongate that. There's an old movie called Zorro, something Zorro, right? Z-O-R-R-O. Zorro, he was, doesn't really matter who he was, but he was a sword fighter, and he would slash a Z into, people he fought against, into their clothes. It was kind of his trope. So if I see a Z, right, I see a Z, I know that I'm going to be dealing with alternate interior angles. Sometimes it'll look like this, where it is like that, right? You have the angle here. It's still the same thing. This angle to here, and then this one to this one. Alternate exterior angles, we're dealing with, and we've proved it here, these angles on the outside are going to be the same, right? That's why I kept them in blue. Those angles and these angles, that is what they are for. Let's talk about the angles of polygons. Okay? For a triangle, we know that it's 180 degrees. Right? For a square or a rectangle, we know that we have 360 degrees. I'll go ahead and put it, maybe you don't know this, but for a pentagon, say pent, that is 540 degrees. But if I asked you how many degrees are in a hexagon, you might not know that. But I'm going to work through this and show you how you can find what the number of degrees is given the number of sides, right? We went from 3 sides to 4 to 5. Hexagon would be 6. Octagon would be 8. Same thing, right, as we go. Heptagon is 7?
Yep.
Yep, great. What we're doing here, what I'm going to prove, is another topic we've gone over, which is just building an equation. Right? We know we have something that fits the mold, that when n, let's put n equals the number of sides. That's what I'm talking about, Levi. When we have n equals the number of sides, you have 3, when n equals 3, 180, n equals 4, 360, and whatever, 5, 4, I'll go ahead and do it. It equals 540, and so on and so on and so on. What we can see here is just we're adding 180 each time, right? But to go from 0 to 3, right, or 2 to 3, we can't just add 180, right? It's almost as if we're starting at, if we were just adding 180 each time, we're starting at 3. So we need something that, when we start at 3, gives us a 1. So let's just say, well, if I do n minus 2, when n is 3, that's going to give me a 1, right? So n equals 3. That gives me a 1. But on the right side, I want this to be maybe not here. Not for this one, per se, right? Because this is going to be our general equation. But for here, I want it to be 180. Well, if I just have 1 here, I need to either add 179 or multiply by 180. I'm going to go ahead and say we're going to multiply. All good? Okay. Multiply by 180. Let's see if this holds up, though. So let's say n equals 4. We have 2 times 180, and that does give us 360. I promise you that the next one will give you 540, and so on and so on, which means the general equation, right, the general equation to find the number of degrees in any polygon is as follows. The number of sides in said polygon minus 2 multiplied by 180 is going to give you your answer, whatever it is. Thanks for watching.
If you like what you saw, you can like, subscribe, or put your comments below.
To watch us live and get your questions answered, check us out on Twitch.